It's okay, Soumya. Shall we? Yeah. Okay.
Yes, sir. We can start.
Yeah. So let me formally welcome all the participants for the today's math clinic session. And before we start, it's my pleasant duty to welcome Professor Ananthnarayan Hariharan. He is in IIT Bombay, so ex-colleague for me because I am nowhere in IIT. It's a pleasure to introduce Professor Anant Hariharan. He did PhD from the University of Kansas, and after working abroad, he joined IIT Bombay in 2012. At present, he is associate professor at IIT Bombay. Apart from doing research in commutative algebra, homological algebra, he takes keen interest in improving math education in and around colleges in Mumbai and also whenever requested for. He is an excellent teacher, which is supported by the awards he has won. The Department of Mathematics Excellent in Teaching Award 2017. And then abroad, he was for 4 years as finalist of Lawrence Black Teaching Award, for 4 years as finalist. Of course, he has been a winner of medals, Institute Silver Medal for his MSc performance and gold medalist for his BSc performance. Today, he is going to talk about a cylindrical boy, and let us see what he can do with a cylindrical boy. So let me leave the platform for Anand. Please, Anand.
Yeah, thanks a lot, Professor Rana. One thing you did not mention, I guess, is that you also taught me when I was a student.
Oh, okay. Thank you.
Yeah. Long before I was a colleague, I was also a student here.
Yeah. So, it's a pleasure to see students becoming colleagues.
So and thanks for giving me this platform to speak on. I mean, I remember you actually contacted me a year ago, and due to health reasons, I declined. And so finally, after 1 year, I'm able to speak in this forum. So yeah. So I just want to quickly check with the participants here. Are you able to see the reactions in the sense? Can you click? Are there yes/no buttons that you can click on? If you can click on, if you can see them, please click on yes. If you can't see them, click on no. Okay, fine. Yeah, I think yes button is available.
They can write. They're typing in the chat box yes or no.
Yeah. Don't type in the chat box, because this is actually one thing that maybe it's against the norm, but I very rarely look at the chat box. It's very difficult for me. So please just click on the yes or no, and I think at least 5 of you have discovered it. So good. So that's what I will use when I ask you a question. I'll try to phrase it as a yes/no question, or I will, whenever you have something to share, click on yes. If you have a doubt, then raise hand. That's more or less the protocol we can follow. So let me begin by, this talk is about assumptions and approximations. Yeah, the title, I mean, I said, consider a cylindrical boy. Perhaps I'll relegate that story to the end. So somebody should remind me at the end to tell you that story. But the subtitle is assumptions and approximations. So main idea behind what I want to do is take up some problem, real life problem. Well, in this case, they'll be very, very simplistic kind of problems. But what I intend to do is just look at 2 or 3 examples and try to see how one can convert into mathematics, what goes on in the background when you want to convert that into a mathematical problem. Okay. So let me begin with a very, very simple kind of a thing. So, I can see that there are about 12, 13 of you here in the session. I'm not sure about YouTube, but so let us say that, one of you, after the talk is over, you go and post that this is one of the best talks I have attended. Okay. And another person goes back and posts that I have never attended a talk like this. It was a complete waste of time. Okay. I know this because you have also shared that with me. Okay. So at the end of the day, I would like to know how was my talk. So I would like to get some kind of a feedback. So what I do is I try to monitor this for 24 hours. Okay, and try to figure out whether the talk was good or not good, whatever the status. So here's a hypothetical situation. So yeah, how would you determine it? Let me ask start by asking that question. How do you think I can determine that? Any of you, if you have an answer, just click on yes, and I'll ask you to maybe say what you think. So the objective is clear. I want to determine how good is my talk. The thing that I know is at least one person has posted that it was great. Another person has posted is a complete waste of time. So starting with this information, is there any way you think that you can, any way to determine whether the talk was good or bad? Any of you, please feel free to click on yes and answer or raise hand and answer. None? Yeah, Soumya.
Probably you will ask some third person.
I would ask one third person. So, for example, so I know my student is there in the talk. I'll ask my student, how was my talk? I know what the answer will be. That may not be a very good idea because I can choose which person to ask, right? So you don't want to give me that choice. And when you ask only one person, things can be very biased. So perhaps it's a good start, but perhaps I want to avoid that option. Yeah, Rajesh Raut, you want to share something?
I think we can assign weights to yes and no, and whichever have more weight, we can take that as.
So if you allow me, I will assign more weights to yes, because I want the talk to be popular. But going to with your idea, what I will do is assign equal weights. Why do you want to assign any random weights, right? I mean, just count the number of yeses and nos, right? That would be one way to do it. Rajesh, would you agree with that?
Yes.
Yeah. Because if you allow me, I will then call the yeses as weight 1 and nos weight 0 or something. So you don't want me to do that. So any other suggestions on what could be done?
There is a raised hand by somebody.
Soumya, that is Soumya. Yeah. Rajiv.
Yeah,
Rajiv?
maybe you can see the number of likes you have got over a 24-hour period.
So that is, that's actually a direction in which I would probably go. Now, let me first of all assume that this posting has been on Facebook so that we can talk about likes. And if it was Twitter, then I would have to look at retweets. But then you see, likes actually have there is a small issue with likes. There are certain people who will always like anything you post. It doesn't matter what you post. So then the like may not give me the real story. So what I would do is maybe I will modify what you said slightly, because Facebook also has this share thing. And this is also there in Twitter. You can also say retweet. Okay? So instead of likes, maybe I look at shares, and I just gave you my reason why. So that's my assumption. Okay? My assumption is I don't want to look at likes because I think likes are skewed. I mean, they can get very skewed. They can get very biased. They may not convey the real story. So my first assumption is I think share is a better, or if it was Twitter, retweet is a better judge of whether they really believe that or not. Okay, so yeah, good. So that is a take I will have, and let's build the story from here. I don't have the time to actually sit and monitor it all day long. So what I do is I just monitor it for the first few hours. So as soon as the talk is over, let's say T is 0. Yeah, Rajesh, you have raised your hand.
No, I don't have question. I was just trying to load that.
Okay, fine. Yeah, sure. So let's at time T equal to 0. I say people liked the talk. There was one person who posted it. People who did not like the talk, I'll just put yes and no for that. Say it is 1. Okay. So this was T equal to 0. Now, I really want to know. So every hour I'm going to check. So T equal to 1, I notice that the number of people who liked the talk is just 2. The number of people who shared, I mean, by like, I mean the number of people who shared it. Okay? Number of people who shared the no was 10. T equal to 2 hours, I notice, I look again and I see no, not sorry. I see that there are 4 people who have shared this. And here I see there are 20. At t equal to 3, here there are 8. And here there are 30. T equal to 3 is already 9 p.m. So pretty close to me to shut down the computer. So I stop. And then based on this data, now I want to say, okay, at the end of 24 hours, this is what will happen. So what do you do? What do you think one should do? So I just noticed for 3 hours, but from this, I want to make a judgment about what will happen in 24 hours. How do I proceed? Ranjit?
Fitting a line like that. Yes.
What do you mean by that?
As we are trying to find out some relations, approximate, okay, and on that basis, we will guess key.
What could happen? So in other words, what you're saying is what is called as extrapolation, right?
Okay, yes.
Yeah. So you observe a pattern here and try to extrapolate it to the given data. So since you brought this up, Ranjit, what would you think would be the information for t equal to 4? If you can see a pattern here, can you tell me what you believe would be the information at t equal to 4? Yeah, anyone? Just click on yes or unmute yourself and speak.
16
yeah, Rajiv?
16 and 40.
16 and 40. Okay. So the moment you say this, that means you've already seen a pattern. Okay. But this is the first step. To when you want to say something about, you have some observed data, and then you want to say something about what happens later. This is extrapolation, but for that you need to observe a pattern first. So what you did is, first of all, you observed a pattern. Then second, you made an assumption. The assumption you're making is that the pattern is going to continue. Okay. So you're assuming that the pattern is going to continue, and assuming that the pattern is going to continue, you said that at the end of 4 hours, this is going to be 16 and 40. Okay. So my question was, what happens at the end of 24 hours? Okay. Well, don't tell me what the numbers are going to be. Just tell me whether the talk was popular or not, or the talk was appreciated or not. So, I think you know what the answer is and you know where you're going. But just for fun, I'll just say what is t equal to 16. Does anybody know what the numbers are for t equal to 16? No? At least the second number should be clear, right? I hope all of you agree that this is 160. And if you don't know what this is, let me just tell you what this is. The only reason I know it and I remember it very well is it was my neighbor's phone number from a very, very long time ago. Okay, so that should probably tell you how old I am. Okay. There was a 5-digit phone number, and that was what the number was. And I didn't observe it. That time we didn't have a phone. I told my friend, oh, this is our neighbor's number. You can call me when you want. And the moment he looked at it, he said, oh, that's 2 raised to 16. And I never forgot it. But anyway, so you will observe the pattern that goes on here is, here you will end up with 2 raised to 24, and here you will just end up with 240. So the assumption you made, first assumption you made was the Facebook post that was posted, the share is a better way to judge. The number of shares is what one wants to judge. Second is, you observe for 3 hours what's happening, and then your assumption is the pattern is going to continue, based on which we are coming to certain conclusions. Okay. So this is what the part of the title was, assumptions. You have, the question was very simple. Was my talk popular or not? That's what I want to understand. So you converted that into a small mathematical problem, given some information. So starting from that information, you converted it into a mathematical problem. You made certain assumptions. Of course, I mean, the way I have stated the problem, I would of course like to conclude that the talk was popular. Okay. So let me stop here and ask you, what did you learn from this example? Please click on yes if you have an answer, because I don't want 2-3 people speaking at the same time. And different people may have different answers. What did you observe from this example? What do you think you have learned from this example? There are multiple things one can.
Yeah, we had very little data initially to extrapolate.
True. True. That's true. But if that's all the data you had, and you had to come up with the answer, this is probably how you would extrapolate, right?
Right. Yeah.
Yeah. So, but what do you learn from this? It's actually something very, very interesting. If you just look at the first 3 pieces of data, the first 4 pieces of data, you can see that the number of yeses is actually very small. The number of no's is much larger than the number of yeses.
Yeah.
Yeah, but that itself should tell you something. The number of
Arithmetic
yeses,
and geometric.
number of yeses are growing exponentially.
Right.
Right? So it's 2 raised to 0, 2 raised to 1, 2 square, and so on. So number of yeses are growing exponentially, whereas the number of no's are growing linearly. So as Rajiv said, it's arithmetic progression. So this should tell you something. This example itself should tell you something. Linear growth is actually much, much slower in the long run as compared to exponential growth. In fact, even if it's quadratic or cubic or something, in the long run, exponential will beat it. So any polynomial growth that you have, exponential will beat it. That's the first thing to know. Oh, actually, that's the second thing to know. First thing to know is my talk was popular. Okay. But there's a third thing to know from this, to learn, is if you don't want the entire world to know something, don't post it online. Okay. So you can see how quickly it can spread. And now all it takes is you post something, 2 more people share it, and then you can see how fast it can spread. So yeah, if you don't want something to be known to the entire world, just don't post it online. Okay. So that's 3 things to learn from here. Okay. So this was example 1. Does anybody have any comments or questions about this? Please feel free to comment. As you can see, it's if you have a different kind of an observation, I would like to hear it. I'll use it in my next talk.
I think you can also interpolate and say something about in between.
Yes.
This data.
Yeah.
From this data alone, one can interpolate and say something about t equal to 1.5.
Correct. Yeah. Yeah. So this is thanks, Professor Rana. So we talked about extrapolation, which is going outside the given interval. So we had data for t equal to 0 to 3, and we went outside the interval. And that's where Rajiv's objection came in. He said, we have very small amount of data, limited amount of data. But we could actually interpolate. In other words, for what happens at t equal to 1.5 is something we could compute by using this data. It's there, the assumption that the pattern stays is better. It does make more sense there than for the extrapolation. Rajiv, you agree?
Yeah, so that's where the question of reliability of interpolation and extrapolation comes.
Right, absolutely. Yeah. Muskan, do you have something to share?
Sir, I wanted to ask if this data follows some pattern. What if it doesn't?
It may not. So that's an assumption you have made. You just don't know because you're talking about the future, right?
Okay.
Yeah, you don't know. It's not clear. So, but a lot of that's where the second part of it, the approximations and all come in. So later on, what you will see is by doing some things, you may end up with some approximate answer. But how accurate is it? One doesn't know until it actually happens. So, no other questions? Then let me continue to the next example. I won't draw a picture here, and then just bear with me for a minute, and then I'll tell you what I'm talking about. If I had made a slide, then I would have just drawn the picture earlier, and then I would have. But I want you to. The reason I want to actually draw it in front of you is I want you to think about what this could be. So I just want, while I draw it, I just wanted to think about what this could be. And you can come up with all kinds of answers. Yeah. Anyone? Garima?
Hostel.
Hostel. It could be a hostel, but no, that's not what I have drawn.
Okay.
Yeah. Anyone? Any guesses?
Is it some kind of a game, video game or something?
Actually, no. No, it's not. But I wonder if there could be a problem by making it a video game. No, it's not.
Like pigeonhole principle?
No.
Is there a dot in the last square or the rectangle?
No. If you want, I can put 6 dots here.
Okay.
I'll put 2 dots here.
Is it a bus?
Earlier, I thought you were making an elephant.
No, it could become a white elephant if you are not
Yeah.
careful. That's true. But
Yes.
Is it a
Yeah.
bus?
a bus. This could be an aerial view of a bus. Okay. So in fact, yeah, that's what I want to say. Yes. I mean, the picture I had in mind was a bus. Yes. And now you can see the number of dots, what the dots could mean. Yeah. My question is, this is a bus, aerial view of a bus. How many people can go in this? Can board this bus? Very simple question. I mean, many of you, when you have traveled in buses, you may have seen up there, no? It says number of standees so and so, number of sitting so and so. How would you even arrive at such numbers? Anyone?
Again, for number of standees, again by approximating how much area a standing person would require. Because for sitting, we would know per seat there can be 2.
Right.
Or in Indian crowded cities could be 3 as well.
Very good, very good. Yeah. So yeah, that's exactly the kind of analysis you would do. In fact, when I said, when I told you that you look in a bus, it says number of standees so and so, number of sitting so and so, sitting capacity so and so. That itself was a hint for you that you should treat them separately. Okay. And the reason is the number of people sitting is kind of determined by the size of the seat. Okay. But if I want to figure out the number of people standing, Rajiv now just pointed out one very crucial thing. He said, I should know how much standing area a person requires. Well, if you know how much standing area one person requires, what is the other piece of information you need to know to figure out the capacity?
How many area is available in bus?
Yeah, bus. What is the area? What is the area available in the bus? Yeah. So, but this kind of information is standard. I mean, you can just look up various things and finally remember approximation. You're not going to get an exact answer. We're talking about approximations. Yeah. Because eventually the kind of question you're going to ask is, well, this is the number of bus in the city. How many people can it ferry? Small, well, anyway. So we are talking about order of magnitude here. So we are going to be approximating. So what, well, I just looked up something today and it told me that this is probably 9 feet. And this is about 27 feet. This was some model I looked up today. It's possible that tomorrow when I do a search, I may get a completely different thing. But assuming that this was my assumption, suppose the bus has size 9, the width of the bus is 9 feet, the length is 27 feet. And remember, nowhere are we talking about the height of the bus. Okay. So at this point, for this problem, the way we are approaching it, we are not talking about the height of the bus. Okay, now, how many of you, okay, what is the standing area? What is the standing area? How do I compute it?
5 by 27 feet.
How did you get that?
I'm assuming that the length of one seat is the seat is 2 feet.
In your experience, is that true?
No, it is just I am calculating that the average area required to seat one person is near about 1 feet.
Probably more, a little more.
Yeah.
But in your experience, see, I mean, this is where we also draw on our experience. When you have looked at buses, do you think that seat is really 2 feet or perhaps longer than 2 feet?
Approximately 3 feet.
So let's say 3. In fact, if you have seen the picture I drew, I actually assumed it's 3 feet.
Yeah, there's equal gap.
Yeah, in fact, I mean, the numbers also help me because of the way things are structured here. Yeah. So In my experience, when I've seen it in a bus, I don't think it's 2 feet. I think it's more closer to 3 feet. So that's the picture I have drawn here. Now that immediately tells me what should be the standing area. Now there's one more assumption we can make. Each block here is a seat and some space in front. So the assumption that I can make is the seat is the length here is 1.5 feet, and this is another 1.5 feet. Why does that play a role? Because that gives me some extra space here. Let me perhaps use a different color. It gives me some extra space here. Okay.
Anant, can I ask? Can I say it is approximately 1/3 of the area standing?
It is approximately, yes.
Can I say so? Here the approximation also will be sort of nice.
Absolutely, absolutely, yeah. Yeah, approximately 1/3 of the that would just work, yeah. So if we use, let's use that. Yeah, in fact, let's use that. So standing area is approximately. That actually makes my life easier. I don't have to do some extra calculations which I was dreading. We can say it's approximately 1/3 the total area. And that is it's 9 into 27 by 3. So which is 81. Yeah, so this is so that was so that gives a standing area. So now how many people standing? How many standees? Yeah, once again, your experience, try to figure out how much space would one person need to stand. What is your guess? You have traveled in buses. I mean, you have stood in places. How in your, I mean, in fact, I can't see you right now, but you actually stand up and check. How much square feet area do you think you would require?
I
Maybe
think
around 2.5 to
1.5.
3.
Sorry, Rajiv?
Around 2.25 square feet.
But what are you saying? 1.5 into 1.5?
Yeah, I'm talking about a square space.
Oh, okay, fine. Ranjit, you're saying something?
Depending upon crowd. If it is too crowded, we can adjust.
Right. So because of that, what I will do is what Rajiv said. I think that's kind of accurate, provided it's not too crowded. So going slightly the other direction, I will say, let's say that per person, let's say it is. You can see a lot of assumptions being made here. Okay? So per person, I'm assuming it's 1.5 into 1 feet, square feet. What Rajiv was saying was 1.5 into 1.5. But as Ranjit pointed out, depending on crowd, let's say, okay, I mean, sideways, I require more space. Front, back, I don't require as much space. So let's say 1.5 by 1. Now you see you have an answer. So total number
that's also an assumption. Front and back, I don't need more space.
Right. But again,
but the way
yeah, go ahead.
People have grown in the pandemic, you might require more space front and back.
That is true. I agree with that. Yeah. Yeah. So, okay. So this is pre-pandemic calculation. Post-pandemic calculation you can do. So number of standees is the total standing area by 1.5. Okay. So you can just figure out what this is. A number of sitting, or the sitting capacity, as we observed it, is like 6 here, 2 in each of these blocks. And this is of course a driver. So don't count the driver and don't count the seat. So 1, 2, 3, 4, 5, 6, 7, and 7 here, that's 14. 14 into 2 is 28. And then 6 here, that's 34. I'm still not counting the driver. Maybe I should exclude the conductor also. But anyway, so this gives us the total number. Okay. So total is sitting plus standing. So it's a very simplistic way of coming up with the argument. And remember, one thing we never used is the height, because you don't expect one person to sit on the shoulders of another. But if you are allowed to go up, that's where a double decker comes in. There you get this extra space above the driver also. So, but of course you lose some space here because you want to build a stair up. So all these variations are possible in a simple problem like this. Okay. Are there any questions or any comments?
Hello.
Yes, Rajesh.
I think in this problem we can also go for lower bound and upper bound.
How would you do that?
Like in capacity is 34 plus 2, so that is lower bound. And maybe upper bound we can.
How would you get that?
Maybe I started calculating, like looking at the last this vertical thing. The 6 seats are there, and assume that there are 6 person can stand. So I think in that one.
Okay. So you are saying like wherever there are seats, you just make people stand there also. Yeah, we could try something like that. And then what would you do with that data? You have a lower bound, you have an upper bound, then what would you do?
Yeah, many times then we restrict our answer, that our answer will be in between.
True, but that could be a very, very large gap, right?
Yeah.
So how would you tackle that? You think about it, because there is an answer that you can give which will be relevant to another problem I will ask you later. You just think about how you could maybe do that. So, but here's the thing to keep in mind. Actually, what something that Rajesh just said can be thought about. See, if I am running the bus, my idea would be to maximize the capacity. Oh, by the way, yeah, I said sitting capacity is 34. This is assuming you're not in Mumbai. Okay. If you're in Mumbai, it's inconceivable that only 2 people are sitting there. I think it's much more than that. Okay. And one of the other assumptions I'm making is, Professor Rana, I'm going to stop sharing this for a second.
Yeah, please.
And I'm going to share something else. I'm assuming that this is not the bus we are on. Can everybody see this bus?
Yeah, there is a Fabicol ad.
Yeah, I was searching for that. I couldn't get it, but I got this picture. So we are also, this is also an assumption we're making. This is not the bus we are talking about. Okay, so let me come back to my screen. Yeah, so anyway, so as Rajiv pointed out, I mean, like sometimes where 2 people can sit, 3 people are forced to sit and all. So you factor in those things depending on which city you're in, what you're dealing with. You factor those local information in, you get better answers. Okay, so that's the thing. Now, I have a question for you, which I would like each one of you to think. And in fact, if you're going to present this problem to students, if you're a student to other students, I would ask you to think about the following. What happens if each person is wearing a backpack on their back? Okay. So then what happens to the capacity? Okay. So what happens if each person is wearing a backpack? Please think about it and learn what you can from that. Okay. So this is a question you can ask. The second question one can ask is, what other questions can you ask? What are the variations can you think of? If I am, I want to run this bus, I want to maximize the number of passengers. I want to maximize the earning from this. What should I do? What would I do?
Restrict the luggage.
Actually, if you look at the picture we have drawn, we have actually not really thought about luggage. So in some sense, we are assuming that luggage is incorporated to that space that the people are using.
We will remove the seats.
Or maybe there are stands on top.
Yeah. So assume that the bus has a. What did you mean by a stand on top, Rajiv?
Rack. I mean.
Racks. Yeah, fine. Yeah, that's fair. Yeah. But Ranjit actually said something very interesting. He said, remove the seats.
Yeah.
If you remove the seat, you realize that you can actually maximize the capacity.
Yeah, there is a problem for our senior citizens.
Exactly. So you want to try to maximize it. So you want to go the direction where you say, I'm going to just take away all the seats. Then I can fill as much as I can. But you can't do that because there are practical constraints. There are people who will require to sit. Assuming you want them to board your bus. Okay, assuming you want them to board your bus. That will...
Probably one should also look at the metro seating arrangements.
Yes.
Each cabin of metro.
Yeah.
What probably you are suggesting is implemented there.
Exactly. That would be my next thing. Yeah. So can the seating arrangement be changed? Be modified to increase number of people?
I have a simple solution for that.
Yeah.
Instead of sitting back to back kind of chair, sort of, no? Like in railways, there are some seats where people are facing pairwise.
Yes.
That allows some people to stand in between also.
Yes, it does. So it definitely does. But the reason is because this space, the leg space, gets shared. So either it reduces the leg space, or like you said, we spread them apart, and there is place for people to stand. Yes. So it does increase the standing space one way or the other. Yeah. In fact, if one of my other favorite problems is to draw the picture of a local and then ask people the same kind of questions. But since this was a diverse audience, not necessarily Mumbai, I didn't put that. But yeah, that's exactly correct. So like you do in railways, we can put the seats facing each other. That actually does change the numbers in some way. The other is, as Professor Rana was pointing out, if you have seen the metro trains, they have seats along the sides. Okay. So that is taking care of the fact that we do require some seats, but it is probably not giving you as many seats as we have here. Okay. It has certain other benefits also. For example, here, this space, the leg space that we have here, nobody can stand there, it's completely gone. But if my entire seat was along the wall, then that leg space that they have can also be encroached upon by standees. So some things can change. So that's this question. How can you change the seating arrangement to increase the number of passengers? And I'll tell you where this problem occurred to me. This occurred to me a few years ago when there was a news article about one of the railway yards in Mumbai trying to refit the local train seating to try to maximize, try to increase the number of passengers. In fact, that's where I got this problem and this whole idea from. Yeah. So there are variations you can take on this. As I said, one is wearing backpacks, one is how to modify seating. The other is you can think about an auditorium. You have an auditorium, how many people can you fit in there? Practical constraints are there. You need a certain minimum number of chairs. There may be space for dais. So this problem is not just about a bus and its capacity. It is just about capacity. There are various things you can ask and answer like this. You can take an entire city and ask, I have this much population. Or how many people can fit into this city? Okay. Now there you'll have to start thinking of for each person how much space you should give. So instead of this 1.5 into 1 feet, I want to live in the city, how much space would I need? So you can start thinking like that. So again, this is a very, very simplistic model, but you can get some reasonable approximations out of this. Are there any questions?
Yeah, while doing all this, another assumption that we have to make is about the safety concerns.
Yes.
So I'm not sure how that would be factored in.
As of right now, in what I did, none. I have not factored it in at all. That's correct. Yeah. So that's exactly what I meant by saying, there will be variations to this. So this would be like the first step.
Right.
If all I'm interested in is how many buses are ferried by, or how many people are ferried by buses in a day in a city, this gives me a reasonable answer.
Yeah.
But if my question is going to be about how do I design a reasonable bus for people to travel in, then one by one, those factors start coming in.
Yeah.
Yeah, that's correct. That's correct. Yeah. So depending on the actual practical problem, there may be other constraints that come in and you keep modifying what you get according to that. And here is why it makes it very, very important to very clearly state your assumptions. Because then depending on what constraint comes in, you know which assumptions you need to modify, which assumptions you need to add. and how things change. Also, you may not like the assumptions I have made. That is fine. You're free to make your own assumptions and come up with an answer. If both our answers are close enough, well, anyway, they're all approximate. It's fine. Okay, so that's something to keep in mind. But whenever one does something like this, it's always a good idea to state very clearly what the assumptions are and how you arrived at your answer.
Anant,
Yes,
I have a suggestion here.
Yes.
Because our buses are rectangular, right?
Yes.
Then we think of seating as rectangular.
Yes.
So this could lead to something like packing problem also. Instead of rectangular, we can have circular seats or some.
Or hexagonal, maybe.
Or hexagonal. What kind of tiling you can?
Right. That would be a variation to this. Yes, absolutely.
Yeah.
In fact, I mean, one way that the way you are suggesting, the way one could think about it is have in this middle portion have hexagonal seating and leave the rest for standing or something like that. I mean, some variation like that, because we will not be able to change the outer walls. So for the hexagons to have like maximum impact, we may want to put them in the middle. So it will be something like in the middle, you will have, I mean, I'm just thinking off the bat here, but I will have one thing like this.
That goes more into designing of a bus.
Exactly, yeah. So, but this is how, I mean, I anticipate that would give you a good answer.
Sure.
Yeah. So, and then like this, and then last is, and the bus is out here. So the standing is surrounding the seating. I think that may actually work. It's just a question of now how would you access those seats and all that. As you said, it's a designing problem. Yeah. So again, I'm thinking completely off the bat here. That may work. One may have to think more about it. I'm not sure. So, okay. If there are no questions about this, no comments about this, let me work out a slightly different question.
You have to keep time for your story also.
Yes. I want you to just stop me when there are 5 minutes to go.
Okay, fine.
Yeah. So that way there will be time for the story. Yeah. So this is, I'm not going to completely answer this question. We're just going to maybe say, how could one answer such a question? Is like, how many barbers does your town have? So how would you answer this question? Approximate answer. Anybody who has some suggestions, you can click on yes.
Yeah, for an answer, or are you looking for a
method? Method. In fact, let's make it more specific so that there is no confusion. Let's say men's barbers.
Yeah, I think only thing is that reminds me of Russell.
Yeah. Yeah. So how would one go about such a problem?
So depending on the capacity of barber key, how many customer he can handle in one day.
Right.
And then how many populations in the city.
How many people actually need a barber?
Yeah,
right.
Correct.
Yeah. That's a good way to begin. Anybody else have any other suggestions? I'll follow it up in a minute, but let me ask if anybody else has any other suggestions. No?
Normally, I ask this question is, what is the definition of a barber?
Yeah, okay. In this case, I mean, it's just somebody who maybe cuts their hair and shaves them or something.
Maybe you should write professional barbers. Then
is this somebody who cuts others' hair or his own hair? That
others. So yeah, so as Raju said, professional barber, I guess. Yeah. So how does one go about it? So I think as Ranjit pointed out, I mean, we can go by the number of hours. That's one example of try to do it. Like, how many hours do you think a barber can work in say a month or something? Then you ask yourself, what would be the population of the city? How many of them would use a barber? What would be the total number of hours a barber services would be required? Now, assuming that the supply and demand are matching, you can come up with an answer to this. So depending on which city you are in, I'm sure there is various census data that you can look up. Again, approximate. So look for you count the total number of men within a certain age group if you want. Assume that's all the people who are going to these men's barbers. You know, you have seen barbers around. You make an estimate about how much time a barber will work in a day. So what is the total number of barber hours you have in a month? What is the total number of required hours in a month? Go from there. Yeah. So this is what Ranjit essentially said. I just modified it using number of hours. Any comments or suggestions here? Yeah, Rajiv?
Maybe also how long a barber takes to service a person, service a customer.
See, I think that will get accounted for in the total number of hours, I guess.
Okay.
Because if I say, like, you know, what is the total number of hours needed by the people, I think that should take care into account. Right?
So that's very intrinsic. Okay.
It is, yeah, it is there, I think, yeah. Or maybe make an approximation that roughly this much amount of time is taken for this job. But yeah, I mean, you're right. I think it should get built in somewhere. But for a very, you know, broad approximation, I think it's maybe we can assume that they all take the same amount of time for the same job. Yeah. So any questions or any comments about this? No? Okay. Fine. So then a slight, well, one more kind of an example I just want to give. So this is like, let me call out. How many of you follow IPL? Can you click on yes if you do? Trupti? Who's your favorite batsman?
Sure, Dhoni.
Dhoni. Yeah, and he's still playing. That's important. So Dhoni is out to bat, and you know, like at the end of 3 overs, Dhoni has scored 20. At the end of 5 overs, his score is 40, and at the end of 7 overs, his score is 55. What do you think his score would be at the end of 10 overs? Okay, so this is open for anybody. Dhoni is batting and is scoring in 3 overs. He has scored 20 runs, 5 overs 40 runs, 7 overs 55 runs, 10 overs. What is his score?
If these are the last overs, Dhoni can score.
It can be anything.
There's no limit.
Okay. So the assumption you're going to make is there is a pattern and the pattern continues. Yeah. Right. So
it could be 55.
It could be 55. But then it's not following the pattern. Right. So the reason I presented these numbers is because what I want to point out is again how mathematics comes in. See, this could actually be my second favorite train, Deccan Queen, leaving from Chhatrapati Shivaji Maharaj terminus. 3 kilometers from the station, it's at 20 kilometers per hour. 5 kilometers from the station, it's 40 kilometers per hour. 7 kilometers from the station, it's 55 kilometers per hour. What speed is it at in 10 kilometers? And in this case, yeah, I mean, there's a reason I chose this train. It doesn't stop at Dadar, which is at 9 kilometers. So you can assume the speed is increasing. Or, I mean, this could have been a question about, the weight of my my daughter when she was born. In week 3, we noticed that the weekly increase in weight was 0.4. By week 5, we noticed that between these weeks, there was a weight increase of 0.8. By week 7, we noticed there was a increase of 1.1. By week 10, where did we expect her weight to be? Do you notice the similarities in all of these questions? So this is what mathematics tries to do. You have similar questions, similar numbers in different places. You abstract it out and you say, this is t, and let's say that this is x. As t takes these values, x takes certain values. When t takes a value 10, what is the value of x? So we write this as a function, and this numbers you can just see. I mean, it's like there's a close relation between these numbers. Once I get an answer here, I can also get an answer here. So you're really saying that, let's say that x of 0 is 0. X of 1 is, x of 3 is 20. x of 5 is 40, x of, when t is 0, value of x is 0, when t is 3, value of x is 20. You can think of t as time, that's why I put t. When t is 5, x is 40, when t is 7, x is 55. And the question is, what is x of 10? Now here, there is no obvious pattern that is being followed. I mean, if you think about it, like the first example, there was an obvious pattern. Here, there's no obvious pattern. So how do you think you will go across about this? Anyone? What would be the easiest way to go about it? Well, let's go to Dhoni. What do you think is the answer here? Anybody? I mean, you create your own method and come up with an answer. And somebody said, 10. I will have 55. Somebody said, there's no way to guess. Dhoni can really do anything. But look at it mathematically. Come up with a reasoning to give me different answers here.
I think probably the column, third column that you have put should give a hint to the possible value.
Yeah, Ranjit, you have one. You have some.
75.
How did you come up with 75?
So difference in 3 and 5 is 2. At that time, difference between the one is 20.
Correct.
And same 7 and 5, difference is 15.
Yeah.
Now difference is near about 3. So just time assuming.
But you see, here the difference was 20. Here the difference is 15.
15, yes.
So then you see, but if the difference was same, then you know what to do, right?
Yeah.
If the difference was same, what would you do?
And like the first problem, we can decide.
It's linear. If the difference is same, it's linear growth.
Linear,
Okay?
yes.
And linear is something that all of us love. Humans love linearity. That's why you always say the more the merrier, even though that is incorrect. Okay? If things were linear in life, we would be in real trouble. I mean, imagine my daughter's weight just growing like this linearly. I think at some point of time, we would have had a lot of trouble. Okay? So linear is something we always like and believe. In fact, that's the reason why humans have a tendency to believe that the costlier the item, the better it is. The malls have extremely low temperatures because they think that the lower the temperature, the more comfortable it is. So in general, I think humans psychologically believe linear is good. So in this case, if the difference was the same, you would have said linear. But unfortunately, difference is not the same. So how would you go about it? So suppose I had only told you at time t equal to 3, 20, time t equal to 5, 40, and asked you what happens at time t equal to 10. What would you have done? Suppose I did not give you the 7 and 55. What would you have done? So this is a case where extra piece of information is actually causing a problem. It's causing more confusion.
Would have done proportionality.
90.
Proportion. You would have done proportion. And by doing proportion, as Ranjit just said, you would have arrived at 90. So what prevents you from doing proportion here? What prevents you from doing proportion? Yeah, Rajiv.
That extra piece of information.
And what about it?
Piece.
What about it prevents you from using
the
proportion?
difference is.
Yeah. So when I do 20 by 3 and I do 40 by 5. No, sorry. No, not that. What I meant is this. When I look at the differences, I mean 40 minus 20 divided by 5 minus 3. And then I do 55 minus 40 divided by 7 minus 5. These two are not equal. Now, those of you who have seen lines, you will know what we are talking about is really the slope of a line. Okay. So what we're really talking about is slope of a line. Okay. So how does one deal with such a problem? So what often one does is use the first two pieces of data. 320, 540 I get. For 10, I get 90. Maybe then I use 5 and 7, use that piece of data. What will I get for 10? I get some value. Then maybe I will use 3 and 7, get a value for a 10. Now I have 3 different values of 10, possibly 3 different values of 10. What can I do with them?
Average.
Average it out.
Average it out. Very good. Which average? Do you want to take arithmetic mean or geometric mean or harmonic mean?
Arithmetic.
Why? The thing
Because
is,
humans love
We are
linearity.
taking difference now, and difference is related with that arithmetic.
sure, fine. But the point I'm trying to make is it's approximation. Okay, they may all give you close enough answers that you don't care which mean you took. Okay, that's one way to do it. But what I want to point out, and this will be my last example before I go to the story, is there is a slightly different way of doing this, where the problem is what you do is you looked at different pieces of data, came up with something here, came up with answers, and then did averaging. The other thing you can do is you modify this value of x, or this value of x, or this value of x. If I modify the value corresponding to 7 to say 60, then I have a good answer. If keeping 20 and 55 as it is, if I'd modified this value to be say 37.5, then I get a good answer. If by keeping these two same, if I change this to 25, I get an answer. Which one should I pick? So this is a slightly different perspective, where instead of solving whatever you can, then taking an average or something, you take the given data. Here you modify this observations slightly. Which one would you take? Okay. So I'm not going to describe what this is, but I'm just going to at least mention the name. So this leads, okay. So x equal to 20, 40, 55 is creating a problem. Okay. I'm just putting all the values together as a vector. But 20, 40, 60, or 25, 40, 55, or you can put the third one, will not. You get an immediate answer. So what we do is you identify a good x hat equal to ABC, for which we get an answer. Okay. And this is what is called as, for those of you who know, at least I've heard the words, this is often known as the method of least squares. Or rather the principle of the method of least squares is exactly this. Okay, so I have this independent variable on which something depends. You modify this, and so that you can get some reasonable answer. Okay, this is an approximation, but this is what we get. So more generally, whenever you're trying to solve an inconsistent system of linear equations, you can do this. But let me not say more about it. Professor Rana, is it close enough to stopping?
Yeah, I think it's time to.
Yeah, fine. So let me just, before I say the story, I'll just ask, are there any questions? Yeah. I have not said anything here about the least squares, but I just want to tell you that least squares also is something that fits in this pattern. It's a slightly different perspective.
I was going to commute story and the questions. So you said questions and story.
Oh, okay, fine.
No problem. Sure.
Yeah. So any questions about what I've said so far? Other questions you can always ask later, but none, then let me just tell you the story. So, there was this very rich man in my village. Oh, by the way, when you looked at the title, Consider a Cylindrical Boy, what was your immediate reaction? Any of you? Any of you? How many of you thought, like, what nonsense? This can never happen. Click on yes if you did. Nobody's willing to say anything. Okay, that's fine. So let me tell you the story. Okay. So the story is this. Okay. So there was a very rich man in my town, and it just happened that he was not always very rich. I mean, he was poor enough that because of not even having a uniform, he almost had to quit school. So it just happened that somebody there donated him a uniform, and so he was able to go to school. He was able to work. He did a lot of stuff. He became rich. And at some point of time, he said, when I suffered, somebody helped me. So now I'm going to do the following. Every single, this is a boys' school. So every single student in the school, I'm going to give them a uniform. So he comes and asks me, how much cloth do you need? Or how much cloth do I need? What do you think my answer to him was? Anyone? Anyone? No?
One only for you.
No. I said for all the boys in the school.
Okay.
How much cloth will I need? I said, consider a cylindrical boy. Can you now complete the story and answer the question? Let me stop here. Yeah, Professor Rana.
Yeah, in the meantime, please do fill up the form and think of how to conclude the story. And if you have any more questions to ask, please do. So we keep 5 minutes for that.
Anand,
Yes.
could you throw some light on the value of R and R squared that we get by regression?
I don't have much of an idea about it.
Oh, because I thought we were doing least squares.
No. See, actually, yeah, this is the thing about when I said least squares, I'm actually looking at it from a very different perspective. I'm not sure how to get that R and R square that you're talking about from here. If you maybe we can sit and talk about it, and then we can figure out exactly what.
Okay.
Because the thing is because I think it's a different language. I don't know that language,
possibly,
but but I'm sure we both know what we're talking about. It's just a different language.
So what happens is when we are modeling, mathematical modeling, say fitting a data, fitting a curve to a data, or model to a data, then at least at school level, students use some software like GeoGebra or Desmos, and they come up with the method, they come up with a model, and that model gives them an inbuilt R squared value.
Yeah.
Okay, and they use that to describe how good the data is fitting, or how good the model is, the model is fitting on the data.
I see. Okay.
So, and then sometimes they don't realize that certain, at times it works when the data model is linear, and sometimes it doesn't work when the model is non-linear.
Okay.
So that is why I needed that clarity.
No, I don't know, because I don't know what this R square stands for, so I'm not sure.
R squared is a coefficient of determination.
Okay.
And
no, but yeah, I don't know what it means.
Yeah, I think
Professor Rana may have an answer here.
No. I just want to say to Rajiv that please get in touch with Anant and
sure.
Yes, interact, because this is more about what we have discussed and what he has discussed today. Others may have some questions on that, right?
Yeah. So Anand, when you said consider a cylindrical boy, so again, are you making an assumption that everybody would have a similar dimensions?
Some kind of average, yes.
Yeah.
Average. Yeah.
Some kind of average dimension. So here, actually, your point about 1.5 by 1.5 would make more sense.
Yeah. Okay.
Right. Yeah.
Only the surface area of a cylinder may be of use.
Exactly. Yeah.
Any more? I hope you're all on to filling the feedback form, because that will help us to get input. Again, collecting data on what kind of talks we should have more on this math clinic. And the starting point that assumption, testing the hypothesis that today's talk was really good. Okay. With so much of confidence, I can say, yes, it was good choice. Okay. So,
I think Garima had a question.
Yeah, somebody has a question, please do.
Yes. So in we were talking about which answer would be better. in terms of approximation. So like in order to get better answer, should we work on getting more data, like more observations, or should we go like modifying the initial set of data to some extent is a better way of going for a better answer?
I think it depends on practical constraints.
Okay.
It just depends on practical constraints. I mean, sometimes you're in a situation where you can't collect any more data, but then you have to have an answer. So what do you do?
Or you can't modify data.
Yeah, then what would you do? So yeah, it's not. So I think probably if you can get some more data, I think the way I would think about it is with some amount of data, I'll try to get an answer. With some more amount of data, I'll try to get an answer. So if I can get close enough answers, I would use that as my approximate answer. See, what do you mean by close enough? It again depends on how much error you are willing to give. And actually, if you think along this perspective, I mean, since I know you are teaching, I can tell you, you can actually get to the definition of a limit of a sequence by using this perspective.
Yeah. Right.
I mean, actually, at least a Cauchy sequence you can get from this perspective.
Okay. Thank you.
Any more questions? So you can always get in touch with Anant. His email is available on the Maths Department of IIT Bombay anyway. And so for more interactions, please do get in touch with him. That is another aim of Math Clinic, not only give you insight into some topics and subjects, but also to make some experts known to you so that you can interact with them. So hoping you will be doing that. Anant, it was a really very nice talk.
Thanks. Thanks. I mean, I enjoyed it. And thanks to the audience also for participating.
Yes.
And I put my email ID in the chat in case anybody wants to.
Yeah, wants to get in touch, please do that. So thank you very much for accepting the invitation, and
Thanks a lot.
We'll rope you in again sometime later on.
Sure.
Okay, thank you very much. Thank you, participants, for joining.
Thank you, sir.
Yeah, please fill up the form, fill up the feedback form so that we can improve if the lacunas are there. Thank you very much and take care. Bye.
Thank you. Bye-bye.